Okay, I'm ready.
Will Alexandros come? No. Okay. Milice, ajde da sad sedete pa ćemo da počnemo. Da. Mislim da treba da počnemo. Just a second. To admit people that they are waiting in. Okay. Okay. Jessie?
Yes.
When you are ready,
okay.
I think that we can start.
Okay.
It's my pleasure to introduce you. They say Nodegoat team. Jessie Labov had one idea very nice for the previous workshop, but unfortunately that was not possible to have that story last time. So we invited her, and she had a great idea to make some broader picture and introduce the Nodegoat team to present us a tool that can be nicely used with our LTEC sub-collections. So please.
Okay. After this introduction, thank you so much, Ranka, for all of your work putting this together. I'm familiar with all of the materials on the website and a lot of the content that was going to be delivered, and I know how intense it must have been. I really want to clarify my role in this particular encounter, and it would have been quite different in the last training school for sure. I'm here more as an ambassador or mediator connecting the work of two different cost actions. One of the ones which I'm most involved in, which is NAEP for Dissent. It's a cost action which started at the same time as distant reading, more or less, which is devoted to the study of the cultures of dissent in Eastern Europe during the Cold War. And it's largely populated by historians, archivists, and some digital humanities types like myself. And so I was very active in that particular cost action and ended up as the vice chair. And through that cost action met Pim and Geert, who are going to be presenting you today with the way they're encountering the LTEC through Nodegoat. So that is important to mention because the origin of this two-session mini workshop is in fact a similar workshop that they held with our cost action, NAEP for Dissent. And in that workshop, one of the things they were focusing on was how you link and enrich historical data. So I'm going to give a tiny little preamble, maybe 5 minutes or so, and just talk a little bit about what I see as the intersection between working with largely historical materials and working with textual corpora and how they fit together and what role Nodegoat plays in those. So after that, I'm basically going to hand the floor over to Pim and Geert. I'll stick around for a little while just to see them kick it off. But I want to make clear that I'm not one of the trainers of this session, although I kept getting introduced that way in the written materials. I really am just introducing the two trainers who will be Pim and Geert, so I don't want to steal their stage. So why don't you guys go ahead to the slide where I very crudely describe the workflow for textual analysis. Okay, so this is obviously a simplification, but I just wanted to mark out in very simple terms something that you all have been doing in great detail, and I think all of us that work with literary corpora arrive at in different ways. But whether we go through computational methods right away, or we go through some manual markup and then later through computational methods, there are quite a few steps that we take, usually from rather large collections of text, to arrive at the level 2 data, which is what you guys have been doing for a couple of days already. So there are many, many more elements of this flowchart that could be added, but I think the key point I wanted to get across here is that usually you're working from a mass of data and then through various different methods, parsing and grinding it down into smaller and smaller chunks until we get at something called level 2 data, which could then be enriched through the means we're going to talk about today. Can you go to the next slide? Okay, so what we have been doing for the last 4 years, I would say Pim and Geert and I together, is working with historians that work very differently. And so I'm going to make the point at the end about why it's important to compare these two. Generally speaking, and this is drawing from my experience, but also from Pim and Geert's experience, from what they tell me, most of the historians they're working with are starting with analog archival sources, so not a big digital corpus like someone, say, who's working with text. And what they're often doing is on the left there, which is actually generating a pretty small data set from their own interpretation of their sources. So what we might have is maybe a couple thousand records total with quite, let's say, detailed fields and different areas that they are interested in, which very easily connects to chronospatial data. Often there's a lot of work in cleaning and refining and reconciling historical names, different toponyms, different spellings, and a lot of work is done at this step of just trying to get a clean structured data set. So that kind of step from analog to manually coding to reconciling is a very typical workflow. Occasionally someone is lucky enough to find some kind of historical source which is pretty consistently formatted, like say records from a particular prison system where everything is kept in a similar format so that it could possibly be digitized and then transformed into tabular data more easily. But even that never goes well. So in other words, it is pretty rare in our experience working with most of the historians we work with that there's a large corpus to begin with. The exception to that might be some of the letters projects, and now more and more when people are starting to work with longer and richer text sources for historical studies. So to summarize, the reason I'm bringing all this up is that we've just gotten to the point, I think, in digital history when a critical mass of historians are interested in working with the same kind of scale of textual markup, of textual extraction, and of level 2 data, which is actually derived from textual corpora, as has been true in literary studies for a long time. And it's exciting for someone like me who's gone back and forth between the two, because now I can speak to both fields about the kind of processes that you guys have been working on with the LTEC in the last couple of days. Now, where I bring Pim and Geert into the picture, and the reason that I was so excited to have them work with you guys, is that they often come in at this stage when people finally have structured data, which can be enriched, and demonstrate, once you have that structured data, all the amazing things you can do with it. So they are not just people who happen to work with a data environment. They are trainers of people all over Europe in different kinds of digital historical methodology. And I'm really excited that they're going to show you guys, I hope it's interesting for you, how far you can go past that level 2 data once you start to enrich and link. So I think that's enough of an introduction, and I think I'm going to turn the floor over to them, but I'll stick around for a bit. And if they want me to explain anything else in the next half an hour, I'm right here.
Thank you very much, Jessie, for this a great introduction about indeed the different fields, and we very much look forward today to explore how these fields can interact and what we can also learn from each other. But you're very much right to point out that this field, this slide we're now looking at, is usually the framework in which we operate. So just going back to the program a little bit, is that now that we have kind of the the spheres of influence established. We will give you an insight in how Nodegoat works, how it operates, how it came to be, and then we will have a break at I think it's in a little bit more than an hour, and then we will get to the hands-on part where you will be able to enter some data into a live Nodegoat environment, and then also explore how some of the LTEC data can be used in Nodegoat and how this can be connected to linked data resources. We saw in the program that you've been doing similar stuff in the last couple of days, so we're very happy to connect to that as well. And what we also very much like to do is have this as a kind of this full program as an interactive session. So I'm not sure how possible it is for the people in the room in Belgrade to say something. Do you guys have a microphone that you in the middle of the room that you can shout to?
Yes, we have a microphone in the middle of the room, so we hear everything that you are speaking all together.
And so if somebody wants to raise something from the room, they can just say it and then the microphone will pick it up.
Yes, microphone is catching everything.
Okay, super. So that's a kind of a central point in the sessions that we will be presenting today, is that we understand that you've been working on complex data, complex tasks for the last 2 days already. So we want to make sure that what we're doing today is as much geared towards your own frame of reference as possible. So if you have any questions or you want to point out something or just say something, please do. So we always like interactive sessions much better than just us talking. So please feel free to break in. Don't wait for us to finish a sentence. Just say it, and then we can take it from there. So that's the kind of the layout for today. We will see how we go time-wise in terms of starting with the hands-on part already before the break or after. We'll see how that works. And I'm not sure if you had breaks before in the other sessions. So I think the first session now we can do without a break, but perhaps the second session we can have a break in the middle as well. But we will figure it out when we get there. So who are we? I am actually Geert. So you see Pim written down to underneath the camera view, but I'm Geert, and that's Pim. And we are based in The Hague, in the Netherlands. We have been developing Nodegoat since 2011, actually, when we started at the University of Amsterdam, where we were both studying, and we got a data set from a professor there who was interested in how intellectuals in 19th century Europe communicated with each other and how fast information could spread at a given point in time. And at that point, there was very little available in terms of data analysis and data visualization possibilities for dealing with spatial and temporal data sets. That was something that we recognized as students of history and of media theory at that time. And both of us also knew how to program. So at that moment, we realized that we could step in this gap and build something that might be useful also for researchers in their research projects. We didn't know of the term digital humanities yet. That was something that we found out later on, that other people were doing the same. But we started with this. We built a first visualization that you see running here on the right bottom of the screen. And after this first visualization, we saw that you could use this for letters, as you see it here, but you can also use it for anything else that has a place, any time attribute. So paintings, people, pottery, anything actually related to studies in the humanities. The first application that we built, we called it the Chronospatial Research Platform. very precise name, but quite a mouthful. So we renamed it to Nodegoat, and that's what it's still called today. So the project that we started with at the University of Amsterdam is still running. So 10 years already, 11. We need to update the slide. And they have since that time generated a lot of data. And as Jessie mentioned, a lot of the data comes from manual data entry. So in this project, you have 400 collaborators who all just literally type in data. So they go to the archive, they read secondary source material, they distill information, factual elements from that, and then they type in this data in a database. The database being Nodegoat, and that's then also the primary use case of most of the Nodegoat users, is that they start with nothing and they build up a data set in the course of multiple years. So that's something that Nodegoat allows you to do, to really focus on a specific topic, and then alone or together start building up a data set based on a specific research question. So this project also has a public facing view. Something also that you can generate within Nodegoat installation is that you can generate visualizations that are accessible from anywhere in the world. And then here you see this geographic network of 40,000 letters sent and received between places in Europe within the early and late 19th century. And this is then something what you can do in Nodegoat is that you can then explore such a network through time and space. And what this professor at that time was interested in is the idea of how information about nationalism, romantic nationalism, could spread through Europe. So there are many theories about how nationalism was able to gain such a momentum. Many people talk about political reasons or economic reasons, cultural reasons. But he focused very much on communication, so that he was able to show that information could spread out very quickly and reach so data coming from Kopitar and Karadzic, communicating with the Slovak or German-speaking intellectuals, were able to exchange information about national histories, national grammar, folk songs, and with that information, we're able to establish the way how a national culture or national history came to be. So that's something that he was able to showcase with such an information network, to show how quickly information could spread within 19th century Europe over the whole continent. He didn't stop at letters. Once somebody's collecting material, usually they also want to collect other kinds of materials. So he also started collecting written sources, music, so national music elements, paintings, which he then categorized also per cultural community. So he was able to gather a lot of data within his database on the national coming to be of many cultures in Europe. So apart from this project, we run a lot of other projects as well. So you can get a Nodegoat account on nodegoat.net. Over 2,000 individual researchers are doing that and are running their own Nodegoat project on our server. And we now have over 75 institutional projects with a university running a Nodegoat installation on their server. So that's also the business model of how we work. So we are a private company and we provide services to these universities. So whenever there's a funded project and they want to have our training and our support in maintaining their software, we come in and we help them running the project for them. So with that, we have already collaborated with a lot of universities in Europe, but also outside of Europe. On nodegoat.net/use cases, there is a selection of projects that have been using Nodegoat. Also, the NAP for Descent cost action is involved. And we are also now keeping a bibliography of publications that mention Nodegoat. Many users obviously don't mention explicitly the database they have been using. Some do, and we then gather them here. So how does Nodegoat work? So what can you expect when you start working with Nodegoat? So first of all, it allows you to define any number of custom data models. So you can implement your own data model. This is something that a lot of historians like because they then are able to tailor the whole environment based on the needs of their research project. However, if you want to connect to other resources, you're also very much able to implement a data model that is aligned with other vocabularies. So if you want to do a Dublin core or CDOC CRM data model, you are able to implement such a data model in Nodegoat as well. And then your data is already aligned with external resources that exist elsewhere. Once you have established your data model, you can use Nodegoat as an individual or collaborative workspace where you then enter data, manage your data, analyze your data, visualize your data. So it's really a workbench where people go for their day-to-day research, where they keep track of all their research and they really use it to manage their project. And then finally, you have the ability to publish this data as well, as it's already on the web. You can quite easily then publish interactive visualizations. You could also then publish your data either as an API or perhaps a mobile app. There are many opportunities to then start sharing your data and also show other people how your data can be reused in other projects as well. With the API that Nodegoat has, it's very easy to connect to your data from other projects. So after this brief introduction, I will now give you some insights in the way Nodegoat works. Yeah. So as I said, you start with establishing a data model, and you do all of this from a graphical user interface. I'm not sure how technically developed this audience is, but it could be that you're very much used to setting up your own SQL databases by just from the command line or doing it in an admin panel. In Nodegoat, you have a graphical user interface that allows you to establish this database just by clicking on these buttons and establishing the model right here. That is something that our users find very helpful because you can use Nodegoat to build very complex relational data structures without the need of having to program. On the other hand, this also means that it might look straightforward, but the conceptual challenges are still or can be very complex. So that means that we also see that some people sometimes hit a wall because they want to do something but are then unable to conceptualize the data model in a way that makes sense. So there we also train a lot of people to think, how can you abstract your data model or your research project into a data model that works when you're going to implement this in any project or any software, for example, in Nodegoat. So what you can do, for example, if you want to work with people, you then establish the way how you want to describe each person. So what fields do you want to generate? And then what makes Nodegoat unique in a sense that it has features especially developed for researchers in the humanities and that you will not find somewhere else, is that you're able to define multiple sub-objects for every object. And these sub-objects are spatial and temporal contexts for one object. So you're able to define, for example, for one person, immediately where this person was born, multiple places of residence, death, and for example, also capacities that this person had. Where the majority of our users come from, namely Excel sheets, this is a huge advantage because they are now able to create this data in a very clean manner and are able to work with multiple variations of the same thing, so multiple places of residence, without needing to work with multiple columns or multiple similar data types. So in that sense, Nodegoat works. This part resembles more a graph database than the relational part that is more related to the static object descriptions that you can make. All right, and once you have developed such a data model, you go to the data section of your environment where you can then enter data. So all the forms for data entry, all the forms for filtering, for viewing the data are auto-generated by the system. So that means that you do not need to create a form like you would do in MS Access or really any other kind of database that you might be working with. Everything is taken care of by the system in this case. So if you want to add a person, you see that this is a direct reflection of what you just saw in the data model. And the same goes, for example, for a letter. So adding a letter is then just a matter of clicking add letter, and the way how you've implemented the data model then also establishes the form that you can use here. As you see here, we have different kinds of fields. So one field is relational. So you can look for people in a database and then assign them as sender or receiver. We can see the sub-objects that we can define for each letter. So we can say that a letter was sent somewhere and that it was received somewhere. If we would look at a single letter here, you will see that we have a sender defined, a receiver defined. We have one date here to also temporally situate this letter. And then for the sender, we have a specific city mentioned. And for the receiver, we have a more broader location. And then once you have entered this data, we can run the geographical visualization. And then you will see this data immediately plotted on a map. And this then also is dynamic, so we can then use the time slider to look at the data from a temporal perspective. Every visualization is also interactive in the sense that you can click on it and then inspect the data that is behind it. So we don't really see these visualizations as a endpoint of your project, but really as a way of interacting with your data, as a way of looking for gaps or for patterns, not so much as a ready-made publication that can be immediately transferred to a journal. So next to this geographical visualization, we can also run the social visualization. This then shows you the relationships that are available in this data set. The red dot indicates that we're dealing with a letter. We have two people, and then we also here have the publication in which this letter has been published. What you also can do, and what other people are also doing, is entering the full text of the letter. So in this project, the researcher was only interested in the network itself and not in the content of the data, but you can enter texts as well here. And these texts can also be tagged. So you can start text tagging, which is something that that many researchers are doing, most of them manually. So just by hand going through letters and tagging mentioned people, mentioned books. One good use case of this is the data of Ingeborg van Vught, who has a lot of letters from Italian correspondent, and she's then tagging them to define his network, to define the things he talked about, the places he talked about. So really an in-depth analysis of correspondence networks. All right, we can do this for one letter, but we can also do this for many. So if I just make a quick filter to find all the letters of the Grimm brothers, I can run a similar geographic visualization. And what you then see, first of all, is a geographic visualization that you would see whenever you would visualize such a network. But what you then can do with the time slider is to look at the dynamics of how this develops over time. So we can now start to inspect how the network looked at a specific point in time. We don't need to make snapshots beforehand and then load that in a different visualization application, but you can just really go through this network in a very smooth manner. And then you will also see the network evolve over time. So at the moment, the center of the network is situated in Kassel. Here you see he has a lot of contacts in Central Europe. The center of the network shifts to Berlin, where he moved, and then his Central European network kind of dries up, and he's more focused on the northern and western parts of the continent. So this is something that you wouldn't see if you would be looking at the complete network, but that you will see whenever you move through this network as it progresses. And that's really an important aspect of what Notecode offers researchers, is that they always immediately have these visualizations at hand. So you can always look at the data. You don't need to export it and then run it in a different visualization platform. The same goes for the social visualization. You can also manipulate this over time and then see how the network evolves. See if people start from the periphery and then move in, or the other way around. So also really look at the dynamics of the network. The chronological visualization also shows you kind of the distribution in time of the data. Let's see if we also have. I think there are some letters from Vuk Karadzic. 19. Let's see. From Leipzig. So you see then how where Vuk Karadzic went and where he sent his letter from. You could also do this for the complete network for these 6,000 letters, and then see where people are and how they or see where the letters are sent from. All right, so we've now been looking at these letters primarily. We can also look at people in this database. So we have the people that acted as senders and receivers. We can also inspect just one person. Let me just close this. So if I look at one person from this database, you see again that we have different kinds of sub-objects, one for the birth of a person, then 4 places of residence, and then 1 death of this person. This we can also visualize, and then you will see how this person moved through time. So there you see that the system itself adapts based on the data model that is entered. So this also, should you plan to create your own project in Nodegoat, you will then realize that all the functionalities are completely dynamic and will form itself based on your input. So this is then the data that has been specified by entering his places of residence. What we now also could do is look at the data where Jacob Grimm has been mentioned in the letters, and there we will see that he has been mentioned as a sender in 430 letters. And from this, we can also extrapolate a biographical outlook of his whereabouts as well. Because if he has sent a letter from somewhere, that usually would mean that he has visited or that he has been in this location. So to do that, we want to visualize only his birth and his death. We don't want to visualize his places of residence. But instead of that, we want to visualize all the places where he has sent a letter. This is also then something that you can do within Nodegoat from a graphical user interface. So to do that, you would open the visualization settings and look at the scope. You would then say, I want to show his birth, his death. I don't want to show his place of residence, but I want to look at his sender relationship and then visualize all the places where he was as a sender. So we want to see the sub-objects where he acted as a sender. If we apply these settings and then run the visualization again, we will see this network appear. And then the purple dots and lines are subsequent letters. we can also then explore this through time. He was born here in Hanau am Main, and then went to Kassel, where he started sending his first letters. Then he made a trip to Paris and back, to Vienna and back, to Göttingen, to Leipzig, and then to Berlin, where he then finally also died. So this is then very much a kind of a data-driven way of looking at somebody's biography, purely by plotting the places from where this person has sent these letters. So that's a good way to show you how this structured data set can be used for multiple purposes. So on the one hand, you can just look at the network of the letters, but you can also use this to see where a person was, and to inspect the places that he visited. Yeah, so you see that the movements of Vuk Karadzic can then also be explored, because you see he traveled quite a bit. From all these locations, he sent at least a letter. And by just following this path, you can then track his movements through Europe. I'm not sure if there's anybody related or interested here in Vuk Karadzic, or if I'm just implying something. All right, so that's how you can look at these people. There are also then other things you can do in this data set. In terms of visualizations, there are multiple options available to visualize data, to, for example, also show uncertainty in the data set. So if I would visualize the letters of this specific Slovak person, then what you see is that we've now have a background layer of the borders of Europe at the time that these letters were sent, and that we have in the right side also a legend that indicates if data was certain or uncertain. That's something that you can build into your data model. So if you're implementing a data model in Nodegoat, you can then decide that you want to store classifiers for your certainty, either binary classifiers like certain, uncertain, or a whole, you are very certain, certain, a little bit certain, somewhat certain, etc. And then relate that also to different kinds of source material. So here you see, for example, that the receiving location and the date were uncertain or unspecified. And then this is now then indicated with a gray color, and that allows you to show or hide this data. And then you could say, okay, this is the data that I'm certain about, but if I also include uncertain information, my data will look like this. And that might be a way to deal with the data that you have available, but that you cannot assess properly in terms of certainty. We can also look at the data from a more public-oriented perspective. And then use the same data set to use different visualization options, and then look at here in this case a actual pixel map, so just an image of this region at that time, and then don't show lines but indicate the directionality of the movement by these moving nodes. And that also then would allow you to share this with a wider audience to show them how the network evolved over time, and where this correspondent had its contacts. All right, so that's more than to the visual side of things. We can also go a bit more analytical. One option that Nodegoat offers is a network analytical module that you can use to run different algorithms: degree centrality, betweenness centrality, closeness centrality, based on the data that has been entered in the database. To run that, you would then specify a scope, again, to see how many times a person was mentioned as a sender or a receiver. You can then run this analysis to get the results. And then you see the people who then have the most letters in the database, or people who have less letters. Another visualization, or another option that we can choose, is the betweenness centrality. So then we don't count the amount of relationships, but the importance of the relationship. So how important the connections are of a person in its network. And then you see that the people with a lot of data still tend to be higher on the list. But here we also see somebody with only 46 letters, but this person has between the centrality almost as high as a person with, let me see, 2,000 letters. So there you see that this specific person has a lot of importance for the network. You can also visualize this then. So now we see this network of people where the size of the nodes is not dependent on the amount of connections, but the size of the node. See immediately why this person has such a high betweenness centrality, because they connect the network of this person, and this whole network around Jacob Green as well via this person. So there you see that a lot of information needs to flow through this specific person, which then tells you that that this is a person of high value for the network. And this is also some of the more analytical things that you can do with historical data, just to assess the quality of the data, to assess the importance of specific elements of that data set, without necessarily using it as a definitive answer to research questions. So you can just use this to see, okay, who was this person? What was their role, and know about this person, and not necessarily publish this, because then you kind of establish that this is the true betweenness centrality of that person, which is something that you will never be able to assess, as you probably will never have all the letters that this person sent or received. So it's very hard to make these claims, but it's very useful in this case to learn more about the people in such a network. Are there any questions so far about Nodegoat and how you can use it for historical research projects?
We have one question.
Yeah. I mean, I have two questions actually. One is regarding the visualization, because is it done using D3, or you have some specific technology behind this thing? And the second one is regarding the analytics or the analysis. Are you using these graph algorithms and centrality measures to other than degree or weighted degree? How do you actually go about that thing? Thank you.
Thank you. It's a good question. So first of all, the geographical values. It's a very important point whenever we're looking at all these geographical data. Then the question obviously rises: well, how do we know where this actually is on the map? So let me just again look at a couple of letters. So what you're seeing here is indeed these nodes. If I click on a single node, I see the letter, and then you will see here for the location, we have two names, but they are not just names, they are clickable elements. So these are references, and we call them location references. So in Nodegoat, you can use locations as a reference to establish that this letter was sent in Berlin. And the question is where, how do we know where Berlin is? Well, we know that because we're using a data set of geonames, and this is a data set that we imported into Nodegoat as a kind of a service for people who are using Nodegoat. They can make use of this data set to quickly geocode their elements. So in that case, you don't need to establish every time that Berlin has this latitude and longitude, but you can just refer to this object in the database. We also here don't by default use the linked data resources. You could do that in a way, but in order to use the data then also in the visualization, you would then also need to load in the actual latitude and longitude that is available at that linked data resource. So you can make use of linked data to establish that Berlin is a city in Germany with a specific URI or with a specific identifier. But then to be able to run the visualization, you would then also do a second step to load in the latitude and longitude data. This is very much possible. So if you want to create your own gazetteer, either manually by just creating your own lists of locations. So say you're an archaeologist and you're interested in archaeological finds in southern Spain in early medieval times, then you are able to make your own list of locations, your own gazetteer for every place that you want to identify. Then just put in manually your latitude and longitude data. That's one way to go about it. The other way is to import an existing.
That's a question in the chat. Yeah.
I will open the chat. Yeah. So there's also an import feature, and Tamara, we combine both the answer both on your question and the question asked before. Is with this import feature, you can import in bulk a list of locations, for example. So if you have a list of locations that you want to work with, you can import this, but you can use the same import functionality to import metadata of letters. So if you aren't involved in a research project that is entering letters for the first time from the archive to a digital format, but if you already have letters correspondence data in a digital format, you can import this into Nodegoat. We will talk about that much more later on. And one thing where you can also find more information about that is in the Nodegoat guides, which has a lot of helpful information in that regard. So let me just go to the guides. Here we have a whole section on importing data. So how to upload a CSV file and then how to connect that to your database. And we also have a section on working with spatial data. So the question before on the way how to create these data points geographically. We will also talk about that later. But there you see that you can either use a location reference, enter your own geometrical data, or latitude and longitude data. And you can then use this to create your own gazetteer or to import a gazetteer. So importing is indeed possible. And then the second, so does this answer the question about geographical data? Person I cannot see, but I can hear. I take silence for a yes.
Sorry, we were muted. The answer is yes.
Okay. Okay, and then the second question, yes, we use a graph database to run these algorithms. So this is a service that runs as part of the Notecode applications. So it takes the data stored in the Notecode database, creates a package, runs it to our a separated service, calculates the data, so calculates the analysis based on the algorithm that we want to use and the data that we send, and then we get the information back, which then can be stored in the database as such. This can also be used for filtering to get all the people who have between the centrality, or to get the people out who don't have any. Does it also answer your question?
Sorry. Can you?
Yes, but do you use clustering also algorithms? Do you use clustering algorithms like, I don't know, Open or something?
We see we
Can you
clustering coefficient. We can calculate. So these are just network analytical algorithms that we provide in this functionality.
Thank you.
All right. Any other questions?
Anna, would you like now ask? No. Okay, later. Thanks. You can go on.
Okay. Yeah. So Nodecode has been used, as we said already, by many projects to analyze different. Relatively big project is at the University of Bern for the Repertorium Academicum Germanicum, where they use Nodecode to map the development of medieval universities in the Holy Roman Empire. And what you see here is a visualization of catchment areas. So the color defines a university, and then the location of the dot defines the geographical origin of a person. So the black dots here are all people who went to the University of Leuven. The green ones, the University of Cologne. Here the red is Vienna, Krakow. So there you see then where universities take their people from. And this is obviously also very interested to run this through time to see how different universities rise and other then start to get lower numbers of students. Next to this large-scale data, you can also use Nodegoat to go very much in depth and also analyze inner city networks. This is a project at the University of Leiden, where a researcher connects literary texts to locations in Rome, where you now also are able to use this as a web app. And then you can walk through Rome, see your own location, and then see the monuments that she has identified, and that you can then read to see the information associated with it. Next to this geographical focus, there are also the opportunity to very much go into the social networks, also to see how they progress through time. The TIC project at the University of Ghent, a project that has also run for over 4 years. They have been analyzing conference visits around the start of the 20th century to see how people connected to conferences, how these people also connected to different organizations, and then the networks that you could create based on those visits. That was a 3-year or a 4-year project with a lot of collaborators, and they also really use Nodegoat to create data sets. So to really enter a lot of data based on the attendance lists of these conferences. This social analysis can also be used in small scale data. So in this case, tags defined based on different articles published in non-conformist art journals in socialist Czechoslovakia. So that shows you that you can then very quickly get an overview of the relationships between content and the actual articles that are being analyzed. So just to go over some of the features that we talked about that are a part of Nodegoat. So as we said, the data models can be defined in Nodegoat by the researcher themselves. And once this data model is defined, it can then be used in any other functionality of Nodegoat. So you are really in charge, and that allows you to define your own research environment based on the specific needs of your research project. Time and space is at the core of the environment. So it's not something that you need to enable with a plugin or something that you need to work with different steps to get it going. But it's really part of what you're doing all the time in Nodegoat. And that then also means that the diachronic visualizations are instantly available. And these diachronic visualizations can be based on a single date stamp and a latitude and longitude point, but they can also be a very complex geometrical shape and also based on chronology statements. This is a feature that's also probably nice to just to briefly show is that you not only are able to specify timestamps, but you're also able to specify more complex date points. So in this case, this letter didn't have a exact timestamp, but was defined in time, relational to other letters. So in Nodegoat, you can make a temporal statement where you say this happened 5 days after the sending of this letter and 5 days before the other letter. And then a period is calculated, which is then used for filtering and visualization purposes. So that really allows you to capture the vagueness or the uncertainty of your dates in a very transparent and explicit manner. You can do this in a very elaborate way. So just to show you, if you want to create these chronology statements, you have an interface available where you can also then incorporate seasons or semesters, biographical data, indeed sending or receiving of data, and then different temporal elements as well. So this is, on the one hand, a very complex feature, but on the other hand, it gives you a lot of freedom to be able to precisely state when something happened. So the environment itself can also be used in collaborative modes. So any number of users can then work together in this environment, where you then can also establish different clearance levels. So if you work together with students, you can give them a lower clearance level so that you can check what they have been doing. You can also do that based on the version control. So every data point can be checked for earlier versions. So you can always go back to an earlier version of something. And also very important in any humanistic research project is that you can add source references throughout your environment. To any statement that you make, you're able to define a source for that. Multilinguality is available. Text tagging, we just talked about it. And also PDFs, media files in general, can also be connected to your Notecode environment. And then already also mentioned before, import and export. So Nodegoat is aimed to be an open system where it can easily get data in other software packages. You can always make an export or use the API to get the data out and then run it in any other programming language as well to make custom visualizations or to connect it to different resources. And from within Nodegoat, you can now also use the linked data resources to directly connect to a resource like Wikidata, and then either get identifiers from Wikidata or dynamically ingest data from Wikidata. It's something that we will be looking at later on. But you're able to also then connect to these linked data resources as well. The public facing site can be also created with these public user interfaces to share your data with a wider audience via graphical user interfaces. And then what we just showed you, these network metrics allow you to calculate different forms of analysis to really understand your data on another level. The data reconciliation process allows you to map vocabularies. So you're able then to, if you have a text and you want to match names, you can use the reconciliation process to analyze those names and where they occur in the texts. Yeah, so we have the guides that we already mentioned, and some a lot of documentation is also available. So if you start using Nodegoat, there are a lot of resources available that talk you through the options. So also for the API, this is all completely described here, how to get it going and where to how to write your queries for the API. And for the guides are then a bit more written as a walk through the system, where you can really start from the very beginning and then build up a complex project by following these guides. Yeah, Nodegoat runs in the browser. Hosted accounts, you can request your own account via nodegoat.net/request account. And as we said before, we provide services for funded projects that want to have training, workshops, support, server management, etc. So that's how we sustain Nodegoat, by providing these projects with services. There's also an open source package available. So if you want to run your own instance, that could also be a possibility. So that's it for our introduction to Nodegoat. Are there any questions based on this presentation?
Thank you very much. It was really inspiring, and I can see from chart and also here from around the discussion, lots of ideas are coming up. But I will now give floor to Anna. She would like to ask you something.
Yeah.
Just a short question. I saw that we need to describe our project to get an account. Could we maybe link a few personal projects to one account, or is it one project, one personal account only? Because I would like to get a feel for the system by playing around with a few ideas, but I don't have a project in particular in mind at this moment.
So I didn't understand the first part of your question. Can you just?
Can one account have many projects?
Yeah. So let me just go back here. This is a demo environment. I can switch here from the correspondence analysis to statuary, and then I get the data model that is associated with this project. And then I can, for example, visualize the data in this object type. So within one environment, you can make different sub-projects with different data models and then run different imports or different kinds of analysis on these different topics.
Thank you. So answer is yes.
Yeah.
Okay, do we have some other question here?
I have a question I wrote in chat.
You have in chat.
Yeah, for Milica.
Yes.
Yeah. So yes. So this is a very good example of this provenance that is very comparable to a biography of a person, or the provenance of a painting, or indeed the provenance of a publication, where you then are able to store multiple publication instances of one book, and then track over time different locations where this book has been published.
Okay, thank you.
Okay.
Yeah, with the Wikidata, I see the question about the if the data in Wikidata is available and somewhat clean, you could also then load that in directly from Wikidata to store that then with the publication in Nodegoat.
Yes, yes, we made them available.
Okay, yeah. So perhaps look at that later on to see if we can ingest that that data.
Yeah, okay.
Yeah.
We will try definitely. Are there some online questions? No? So what you suggest for, do you suggest a short break and then go to a next, or I think that
So the
yes,
the next part of the program
to have a short break now and then continue. Should we say 15 minutes break?
Yeah. Super.
Okay.
Yeah.
See you then.
See you then. Bye bye.